Hello everyone, myself G.Karthik Reddy, Associate Professor, Department of ECE from MLR Institute of Technology, Hyderabad. And today I am going to introduce the course on the subject of probability theory and stochastic process. Here in this subject, you are having the concepts related to the probability. Next, we are having the random variables. After that, we are having the concepts related to multiple random variables. Then you are having the concept related to the stochastic process. And today's concept, we are going to discuss about the introduction to the probability. And today's topics are prerequisites, what are the prerequisites required for the probability, and what is the definition of sample space, and what are the types of sample space. And next, I am going to introduce related to the probability. Now first, to study the basic of both the probability, first you have to know the experiment. What is a physical experiment? A single performance of the experiment is called trail. Single performance of the experiment is called trail, for which they will get some outcome. That is called as outcome. And next, probability is defined in three ways. That is classical definition, and second one is definition from the knowledge of set theory and axioms, and next, concept of relative frequency. Individually, we will explain in the coming slides. Now, next, what is an experiment? Any physical action can be considered as an experiment. Any physical action. For example, tossing a coin. If you toss a coin, you are getting an outcome of either head or tail. Okay. Next, throwing or rolling a die. Okay. When you roll a die, you are getting the chances of outcomes from 1 to 6. 1, 2, 3, 4, 5 and 6. 6 possibilities are there. Next, drawing a pack of cards. From drawing a pack of cards, you are having the total from 52 cards, you are having the different probabilities. Okay, these are the different examples of an experiment. Next, what is sample space? What is sample space? Set of all the possible outcomes in an experiment. Set of all the possible outcomes. For example, if you toss a coin, what are the possible outcomes you are having? If you toss a coin, head or tail. If you roll a die, what are the possible outcomes? Those are 1, 2, 3, 4, 5 and 6. Okay, these are the examples. And it is all the possible outcomes of an experiment is called sample space, and it is denoted by S. It is denoted by S. The sample space, another definition is called, it is a universal set of the experiment. Universal set of the experiment. Okay, for example, okay, if you take the Venn diagram, in the Venn diagram, all the events which are possible in a Venn diagram is called sample space. Means all the possible outcomes which you are satisfying in an experiment is called sample space. Okay, you are having the different types of sample space. Those are discrete and finite sample space, discrete and finite sample space, and discrete and infinite sample space, and next continuous and finite sample space, and continuous and infinite sample space. Okay, I'll tell with an examples. If you toss a coin or throw a die, you are getting some outcomes. For tossing a coin, you are getting the outcomes head or tail. For rolling a die, you are getting the outcomes as 1, 2, 3, 4, 5 and 6. All these are called possible outcomes. This is called sample space. Sample space. This is called sample space. And for example, each and every outcome is called as sample point. Sampling point or sample point. Sample point. Now next, okay, here discrete and finite. Okay, you are having the discrete sample space and finite number. Example, you can take this example, tossing a coin, rolling a die. Next, discrete and infinite sample space. If you are having discrete and infinite sample space, you are having the example here, you are having choosing a randomly positive number. Choosing a randomly positive number, the sequence you will get from positive number from 1 to infinity. You are having n number of outcomes. N number of outcomes which are uncountable. That is why in the sequence you are having integer number of values from 1 to infinity. That is why it is called as discrete and infinite sample space. continuous and finite sample space. Continuous and finite sample space, the continuously the spinning wheel or spinning wheel pointer is rolling continuously. You are having the sequence samples from only up to 0 to some example. You are having the spokes of the wheels from 0 to 12 example. Okay, 0 to 12 spokes. You are having the continuous samples in between 0 to 12 in between these interval. Okay, that is called continuous and finite sample space. Continuous and infinite sample space. You can take any random signal. For example, you can take the temperature variation in a particular day. It is varying in a different manner. Okay, you have to measure each and every instant of that sample space. That is why that is called as continuous and infinite sample space. We can also call that as random signal. Now next, I am going to discuss about the introduction to the probability. In that, one of the most important one is variation or difference between deterministic and random models. Probabilistic models is also known as random models. What is deterministic experiment? An experiment whose outcome can be predicted with maximum certainty. For example, here you are given as sun rises in the east. Sun always rises in the east. We know the outcome. That's why you are having the maximum certainty. That is why this type of experiment is called deterministic experiment. Okay, I will tell some more example. If you toss a coin of biased coin means two sides having the same either head or tail. For example, two sides you are having. In a coin you are having two sides. Okay, in two sides you are having both the sides you are having head or both the sides you are having tail. Okay, when you toss a coin, you can predict that compulsory. If you are tossing a coin of both the sides head, you can say that the predicted value is head. And similarly, if you toss a coin of having both the faces of tail, you can predict that it is having tail. That is why these type of examples you are calling that as deterministic experiment. Non-deterministic experiment. An experiment whose outcome cannot be predicted. For example, say if we take the same example coin, but here in this case we are taking the unbiased coin. In unbiased coin, what it tells that in both the sides having different faces. Means one side you are having head, other side you are having tail. Okay. Now if you toss a coin, we can't predict that either you may get head or tail. Getting or not? Okay, either you may get head or tail. But you can tell that the probability of getting head is 1/2 or probability of getting tail is 1/2. Okay, now from this I can tell the definition of the first definition. Probability, probability of an event. Event is for example, I want to select the head. What is the probability of getting head? Probability of getting head is an event. Okay, the definition is the number of favorable outcomes. By total number of outcomes. Okay, again I will rewrite this. P of E is equal to number of favorable outcomes by total number of possible outcomes. Total number of possible outcomes is sample space. Okay, you can also write this as N of E by N of S. The total number of possible outcomes is called sample space. For example, in the just now I discussed tossing a coin. You are having the possibilities is either head or tail. Okay, if you take the event of getting an head, then what is the total number of possible outcomes? two possible outcomes. In that we want head. Then in the 2 you are having only one chance, that is probability of getting head is 1 by 2. Similarly, probability of getting tail is 1 by 2. Probability of getting tail is 1 by 2. Now I am going to discuss about what are the different types of problems. They will discuss from the concept of probability. In general, the probability problems are classified into 4 types. Keyword based problems. What are the keyword based problems? Like for example, they may tell that okay, either A or B or both, okay, or A intersect B, or A and B are independent events, and A and B are mutually exclusive, and A and B are exhaustive. They may tell some keyword based problems. These are related to mostly the problem based. Okay, just you are having only the formula based problems only you will get from keyword based problems. Next, you are having the standard pattern. Next classification. In standard pattern, you may get the problems related to the coins. You may get the problems related to the dice. You may get the problem based on playing cards. You may get the problems related to the box, or they may call this as on. Okay, either you may get the problems related to the coin, or either you may get the problem related to dice, either you may get the problem related to the playing cards, or either you may get the problem related to the box or on. Next type of classification, they may ask the problems related to the conditional probability. Conditional probability. Conditional probability. Next. Okay. Next, these all concepts I will discuss in the coming portion. Next, you are having the next type, total probability. Total probability or Bayes theorem. Okay. In the probability concepts, most probably they may ask the questions from these 4 classifications, either keyword based problems or standard pattern, either from the problems from the coins or dice, cards, box or urn, or either they may ask from the conditional probability concepts, or either they may ask from the Bayes theorem or total probability concepts. Okay, these are some of the topics related to this. Okay, for example, okay, first we will start with the standard variation or standard one. In standard pattern, I discussed coin. For coin, how many possible outcomes you are having? For tossing a single coin. Tossing a coin, you are having only 2 possibilities, either head or tail. Either head or tail. Next, for rolling a die. Rolling a die or dice. Rolling a dice, you are having what are the possible outcomes? What are the total possible outcomes? You may get when roll a die, either you may get 1 or 2 or 3 or 4 or 5 or 6. Okay, these are the possible outcomes when you roll a die. When you pick up the pack of cards, deck of cards, okay, cards. In cards, you are having total number of cards, 52 cards you are having. Total number of cards, you are having 52 cards. In the 52 cards, okay, it is split into 4 portions. The 4 portions of the cards which we are using is, one is spades, one is heart, next one is diamond, next last one is clubs. Okay, each having the count of 13. Count of 13. Okay, in each set of 13, you are having ace. Next starts from 2, 2, 3, 4, 5, 6, 7, 8, 9. Next you are having king, queen, jack. Okay, and you are having the sequence of this. How many count is 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 10 also. Okay, these 13 cards it is you are having in the for spade, for heart, for diamond and for club. And the last standard pattern if you are having, that is box, or some textbooks they are calling that as on. Okay, box or on. Okay, in this box or on, selecting the box, or in the box you are having certain number of items like balls. Okay, they may give different types of examples they are giving. Next I am going to discuss about some concepts related to the coins. First we will start with the concepts related to the coin. Okay, before discussing the coins concept, okay, we discuss the coins concept related to the single coin. If two coins, for example, if two coins are tossed simultaneously, if two coins are tossed simultaneously, what are the possible outcomes you may get? What are the possible outcomes you are going to get? Okay, the possible outcomes, total possible outcomes is called sample space. What are the possible outcomes? Both the coins may be head. Okay, first coin may be the head and second coin may be the tail. And next, third possible outcome is first coin may be tail, second coin may be the head, and the last possible outcome is both the coins tail. Okay, you are having 4 possible outcomes you are getting in this. Okay, now next we are going to discuss about the next concept. If you are having all the possible outcomes in a sequence, this is called as sample space. Okay, all possible outcomes, this is called sample space. Okay, if you take the Venn diagram, this is a sample space. Okay, this is a sample space. Just I am taking one example. I am considering this as lambda 1, this as lambda 2, this as lambda 3, this as lambda 4. The same thing I am going to denote in this lambda 1, lambda 2, lambda 3, lambda 3, lambda 4. Okay, each and every lambda, okay, for example, each and every lambda represents the sample point. Okay, sample point. And if I want tossing a coin having 2 heads, or tossing a coin in when you have 2 coins are tossed simultaneously, I want both the coins must have same either head or tail. Okay, then you can have the possibilities. Okay, you can have the possibilities, that is, you can call that as event. Okay, you can call this as an event. Event. Okay, each and every sample point also we can call as an event, and from this we can conclude that each event is a subset of sample space. Event is a subset of sample space. Each and every event is a subset of sample space. Okay, now next. We'll take one more example. Okay, if you roll a die, what are the possible outcomes? 1 to 6. 1 to 6. These are all the possible outcomes when you roll a die. Okay, when you roll a die, okay, for example, you take an event. Okay, it should have even faces. if we, okay, the probability of event A, consider that it should have even phases. Even phases means what are the chances we are having? 2, 4, 6. Next, if you want to get odd phases, I am considering that as event B, odd phases. Then what are the possible outcomes? 1, 3, 5. Next, you consider one more event C. Event C. Okay, you are having the, for example, prime phases. Prime phases of a dice. Then what are the possibilities you are having? What are the possibilities you are having? Okay, prime phases. What are the prime numbers? 2, 3, 5. Okay, if you want to draw the Venn diagram for this. Okay, if you want to draw the Venn diagram for this. Okay, this is a sample space. And what are the events we have taken? Event A. Okay, event A. Next, event B. Next, event C. Okay, in event A, I considered as what are the event phases. Event phases are, what are those? Event phases. You tell me the event phases. Just now I discussed 2, 4, 6. And next, second one, odd phases 1, 3, 5. Next, third one, prime phases 2, 3, 5. Okay, these are the possibilities. These are the possibilities of related to this. Now next, now each and every event, okay, here this is an event and this is an event and this is an event. Okay, this is an event. Okay, check. Okay, in first case you are having the possibilities 2, 4, 6. In second case you are having possibility 1, 3, 5. In third case you are having the, what are the outcomes? 2, 3, 5. 2, 3, 5. 2, 3, 5. Okay, these are all the possible outcomes related to this. Okay, I think you have some idea now. You have some clarity related to what is sample space and what is sample point and what is an event. Okay, what is an event and what are the different types of events which we have discussed into it. Okay, we have to know that, okay, tossing a coin, okay, tossing a coin, or when you are having the trail, okay, they can call, sometimes they may call trail of chances. Okay, trail of chances, they may get the trail of chances. You may calculate the, what are the trail of chances of tossing a coin, head or tail. We should take the outcomes. Okay, what are the possible outcomes? You have to know possible, all the possible outcomes is called sample space. Okay, event is a subset of sample space. Okay, thank you.